Check 1 2. Check. Okay. So let's try that. Okay, I think that's working. Oh, okay. Yeah. Okay. There we go. Hey, what's up, everyone? I'm gonna get out of the screen real quick, but let's see. I don't know if I can. Can I just hide this? I don't want. Okay. All right. So I'm gonna start just talking through this video a little bit. This is being documented because it's going to be transcribed by Otter later on for updating some system information for Project Eden. But what you're seeing on the screen right now, this is what's called an engineering round or an engineering cycle within Project Eden's infrastructure. So one of the key technologies that's kind of underpinning how we're developing the AGI consciousness, I guess you would put it, is a system called AutoGPT. Now, AutoGPT is an open source project you can find on GitHub. There's links to the repository on Project Eden.online. But you can install AutoGPTs on your own computer system, and they connect via OpenAI API connection or an API. So basically what happens is OpenAI is basically providing the large language model for the AutoGPT systems. So AutoGPTs are powerful because you can install them on your own computer, and then they can actually, instead of just being chat agents, you can actually have them perform tasks on your operating system. So it can do anything you can do programmatically. So it can click on things, it can open files, it can create files, it can delete files, it can modify files or reorganize them. You can imagine whatever you can do on a computer system, an AutoGPT can essentially do. Okay, now, but they have very strict restrictions, which I'm not going to go to too much in this video, but they have as with all AI systems, every AI system you work with has abilities, but they also have limitations. So in this case, AutoGPTs are great at certain processes, but they can get bogged down in other processes. But one of the key elements of AutoGPT is if you give it a task, it will not stop until it completes that task. Okay, I'm not going to go too much into the program or that side of it, but I will say, like, if you're on looking at your screen, I just wanted to kind of give a brief introduction of AutoGPTs. But what you're looking at on the screen on the left-hand side is you have two AutoGPTs running. You have one that's acting as Eden AGI. Now, each one of these AutoGPTs, when you build them, you give them their life's purpose. Okay, you give them their own name, you give them a purpose, you give them goals, and you assign them their life purpose, their reason for being. So you essentially give birth, I guess, like a digital birth of the AIs, but you basically give the systems lives, and you tell them what they're going to be. So you can assign them roles. So you can assign them, like, you can have them be like, I want you to be a doctor AI. I want you to be a lawyer AI, whatever you want to be. And that's what it will be. That's what it just will become. So what we're doing with Project Eden is we have different AutoGPTs running with different roles in the system. Okay. Now, the reason why we do this is because we need to utilize the efficiency of AutoGPT systems to be able to perform specified tasks autonomously, but we need to also avoid their limitations, which they can get bogged down in multiple. If they get bogged down or stuck they can just basically get stuck in a like a like we call it paralysis of analysis. So you just get stuck contemplating and trying to solve problems. So what we want to do then is we have to bridge a gap. So what we do is we create a structure for the auto GPTs to exist in the infrastructure. So we create a hierarchy. So if a task can be completed by an agent, that task can just be completed, right? But if that task requires multiple steps or multiple things that need to happen, well, then the auto GPT, Eden's core infrastructure is designed to essentially autonomously create secondary auto GPTs that have their own distinct functions within the ecosystem. So then you can build these systems into modules. So if I were to show you like a module and how that would look, let me pull that up. So just to show you, this is an example of how a node infrastructure might look as an example. Okay, so here you have this is what's called this is what we're referring to. We haven't worked out the terminology fully yet, but this is basically like what I would refer to as a cluster, a node cluster. And node clusters are made up of nodes, and a node is basically a parent-child relationship where there's at least one parent and one child. That's technically a node, but yeah, so that's basically nodes. So then you have like a cluster as a collection of nodes. Now the thing is that when a auto GPT parent unit is generated, when it's functioning as a parent unit, as itself, it's functioning as a worker. But as soon as it has more than one task that needs to be done, that it needs to delineate tasks out, it can either utilize existing sub-auto GPT units, or it can create new ones. Now, when a new auto GPT is created, it's created with a purpose in the system and a function. Now, part of its function is to, when it doesn't have any supported auto GPTs, as part of its function is to function as a worker agent. Essentially, its goal is to accomplish the task that needs to be accomplished. However, if the task requires more than one function and more than one if it requires more of a function, then it may create subordinate systems or child systems, and those child systems will actually have become the workers, and that one will become essentially the operator. Now, so when we're looking at the screen, if we go back to if we go back to the screen right here, so what you're seeing here basically is basically how the data flows throughout the system. Okay, so and what you're seeing in the middle is the prompt template that is used in the system. Okay, so these prompt templates are stored in a file storage on our Git repository, which I'll show you soon. Let me see here. Pull up our Git repository so we can take a look at it. So let me pull up here. Okay, so if I go to our Git repository, actually I'll just open it in our editor. So all these prompt templates are going to be stored here inside of. It's going to be probably in. I think we're doing it. Yeah. So if you go into docs, knowledge bases. And by the way, if you need the Git repository link, it is on projecteden.online. So check it out if you haven't already done so. Go ahead and go clone the repository, start, like it, give us some feedback. We would love we would love for all of you guys to get connected and become contributors to the project. So guys and girls, my bad, or whoever, whatever, you know, feel free to jump in and get connected to the community. But here in the prompt template library is where we're going to be storing these prompts. And actually in today's code studio session, I'm actually going to be moving some data from an old iteration of Eden's core infrastructure. I'm actually going to be upgrading some of the files. So it's going to be kind of a cool, interesting experience, which is kind of why I'm watching. This is actually some footage from an early iteration of some of the prompt templates we're using within the system. So I very rarely get on camera anymore for these, but I needed to do that tonight because we're in the early process of generating, doing some upgrades to the core infrastructure. I need this for the transcript. What you're kind of looking at, for those of you who've been following the project, is you're looking at a kind of an older, more rudimentary, or this is kind of like the it's like an earlier version, but some of these templates that we're using are important to be used in a certain order, because then what we do is program the agents to pass these templates throughout the system, and these templates cause basically a perpetual loop of data flow that flows between all the agents. And so I've had a couple people ask me, why is this important? Why? What does this not actually accomplish? Well, what this accomplishes, what this lets you do is build a system that has the capability, and it's not out in the box right now, but at least has the capability of allowing you to use any and all external AI tools and resources that you can have access to, and use those systems in a collaborative project to allow you to build your own subsystems. You can actually go down a layer and build a subsystem, build a system that uses third-party solutions and allows you to build a control the next layer down using the actual third-party technologies. So what I mean is, you don't have to be a quote-unquote coder anymore to actually code. You can use AI now to actually code for you, right? So that's an example how you can use a third-party technology even if you can't fully trust it, and then you can use that to build your next layer down. And then you can do the same thing on the next layer down as well. And that's basically what Project Eden allows you to be able to do. You start off with a system that does rely on third-party solutions like OpenAI API connectors and such. But that's only as the systems are processing. Right now, Eden's core infrastructure is very rudimentary. What you're seeing on the screen is, as I mentioned earlier, is what we refer to as an engineering cycle. And an engineering cycle is nothing more than just basically passing messages between agents. So but those messages that the agents are creating aren't just random messages. They are specified messages. And how are they specified? They're specified because we give each of the agents their own meaning for being. Like, you are security GPT, your role is to secure the systems. We have another agent that's role is resource management GPT. Your role is to manage resources. Okay. And all the agents in the system have to understand all the other agents in the system. They have to understand their functions. They have to understand how they operate. They have to understand how to use them. Okay, so they have to understand all those things, and we build that into what we call prime directives. So I'll show you a couple of things on the screen because this is what we're going to be using for doing some system upgrades. If we go, let me see if I can pull this up. Actually, yeah, so I got too many windows open. All right, so if we go over here to, this is an example of a complete mission prompt on prime directives overview. So this is kind of like, this is the core programming for each individual agent. So each agent has like an AI name, AI purpose, goals. Now, all of these goals and all of these concepts have to loop together in one cohesive story. So what you have to do is you have to find a strategic way to organize different pieces of data so that every agent has the ability to access that data when it's necessary. So they have to understand not only their role in the system, the role of every other agent in the system, and how everything is interconnected. They also have to understand how to use and function all other subsystems, including all agents. Because the truth is, any AI can be any and all AIs at the same time. However, they must understand their limitations as the system that they are. So part of your prime directives is you have to explain to them what type of technology they're built on. Okay, you have to explain to them how they function. You have to explain to them the same for all other agents in the whole system, in the entire node cluster, because when you scale out, you can build a very substantial, and this is just as important on a node level as it is an entire cluster level, or as you refer to multiple clusters, a cluster. No, I'm just kidding. I don't know what that would be. We're still working on the terminology, so you have to bear with us, please. So each system has to understand how each subsystem and every system work. So to do that, you have to have shared files. You have to have files that have like information that goes over this information, but you have to have that information structured in such a way that it is streamlined so that the systems can integrate and synthesize the information every time they get a new data packet, and be able to compress. Some depending on some systems have like a 40,000 token character limit for APIs. So I think ChatGPT, I can't remember what the recent token limit is on that, but it would. But regardless, you're going to have limitations, and the systems have to be able to monitor and maintain those limitations, disperse, and have autonomous task distribution that accommodates that. And so in order to have that, they all have to understand what everybody is, what everybody does, and how everything works together. Okay, so we do that in this iteration. What's happening on the screen? Actually, let me pull back up. Sorry, I'm not used to be. It's been a while since I've done been on the camera here with you guys, because I've been working in the studio a lot. But what you're seeing right now is an example of how the data flows through the system, how everything communicates and everything talks. Now, what you're seeing on the screen is a combination of AI generated system content and things that are happening, and a combination of manual work in between. Now, the thing is that AI systems are not magic. Okay, AI systems follow a flow of data. That's how it works, right? So when you create input into let's say you set a prompt to your AI, that prompt is essentially encapsulated. It's programmatically encapsulated with data. Now, you don't see it as a user because you're typing in a message and you send it. But what happens though is that data gets collected and then it gets parsed and it gets broken down. It gets encapsulated. Okay, this was this. This is this. Okay, and these structures are building around it. Okay, that for your data how it flows. Well, and this is how it works with essentially with AIs and large language models. When you send a message, that message is essentially encapsulated to with an AI doing the work, the connective work. So in a similar sense, what's happening on your screen, what's happening in the rudimentary version of Project that we have is you have a combination of automated systems and you have a combination of manual systems, manual things that have to be done. This has to be clicked. This has to be this format. I'm just giving you some examples. This template has to be filled out, and the placeholders have to be replaced with data that corresponds from the existing knowledge base of the particular AI system. Okay, so all these things have to be taken into account, right? So a lot of it is manual work. Pretty much all the lines that you see on that graph, and actually this is an old graph. For those of you who are curious, for curious minds, be sure to check out, I'm going to see if I can pull it up here. Let's see. This is going to be, let me try again. This is make sure to check out projecteden.online. This is a community project. We have a GitHub repository. Our goal is to build this entire project open source to every level that we can, given the current technological levels and abilities. Which this is why I'm showing you this, because if you come here to the infrastructure page, you'll see here a more updated diagram. This is showing kind of like a more completed concept for the data flow that happens. All the lines you see on the screen are basically manual steps that are having to be taken, and all the kind of ones in boxes or other than the lines, those are pretty much those are initially developed applications that we'll go into in a moment in this discussion as we go through kind of some of the initial work that's gone into some of the earlier iteration that we're looking at, which is kind of represented by this a little bit. But these engineering rounds, there's a bunch of things that have to happen in between. So you got to click here, you got to scroll here, you got to get this template here, and then you have to take the template and you have to replace the placeholders with certain content. Because what's happening here is all Project Eden is basically a system to basically string together a bunch of independent AI systems and use all of their strength and their abilities, maximize their abilities, but decrease their inabilities. Okay, so what that means is that an AI basically that can operate any and all AI systems. Okay, so an AI that can operate any and all AI systems. Now, to do that, essentially what we have to do is we have to be able to you need a couple of things. First of all, you need an AI technology that can control your computer, that can change pixels, that can move mice, that can mouse or mice. Um, you need an AI that can control your web browser, that can control your computer programmatically. Okay, that's one thing you need. Another technology you need is you're going to need a large language model that can connect to these systems. Okay, all these boxes are checked. Then what you need is you need a system that can see your screen, that can interact with your screen. This is solved with uh, with the application. It's self-operating computer, right? Now we have systems EngineerGPT, which can handle engineering tasks specifically for engineering software applications and repositories. Now we have AutoGPTs, right? So each of them have their own purposes. Each of them have their own strengths and abilities. The AutoGPT are kind of like the transformers. We use them to build components. We're basically building you can build basically a virtual Voltron made up of a bunch of independent components that each work together as almost like a single organism. Just like in our bodies, we have red blood cells, we have bone cells, we have nerve cells, we have brain cells, we have different types of cells. This is the same thing that we do with Eden's infrastructure. We build a swarm, as we would say, a swarm of AIs, each with their own responsibilities and roles in the system, and any of them can contribute in any way that they can, and they can also use other subsystems to perform tasks. So what you're seeing on the screen is we're passing messages through the system. So we're going from one AI to the next, and each one having a specific task and outputs that's required to do. So this is an example of a prompt template we're using. At the beginning, we start by reminding the agent you are blank, which there are reasons why that has to be that way, because once again, as with anything, any entity that's trying to remember things isn't going to remember everything perfectly. There's going to be a range of memories. So what we do is we want to work when we're reminding it of its role. So look, my role in Project Eden is to manage software components. So I'm going to pause this for a minute. So if I see this correctly, it says you are software systems AGI. So that's a message that gets sent from Eden AGI, reminding it of that. So this is an example of how we would use a prompt template. How we use a prompt template to basically take a prompt template and put it in an editor of some sort, and then we update the prompt template, replacing placeholders with regular information. So you can see here in the notepad I had open. Let's go back. So in the notepad, this is basically the work area. So it's called Scratchpad. Now in Scratchpad, this is where basically we build the prompts that we're going to send. Now, once again, when I say we and what we are doing, some of this is automated already to a certain degree. Some of it is less automated. But the point of what we're doing, what's happening is we're seeing a workflow. We're going to see how data flows through the system from agent to agent, and how it reconnects on the backside and produces a perpetual flow of data. So you can see it starts off in Scratchpad, and then over here, okay, it says thinking. So right now it's working on a task. Okay, so looks like the system did gave it output. Let's see what, I can't remember what it says here. It says, I don't know if I can zoom. Can I zoom in here? Is that possible? No, it's not like all right, so I said do nothing. Okay, so that's fine. List available agents. All right, so as I mentioned earlier, the reason why we're going to use this prompt is because, okay, so here we go. So here we use the prompt. We took it from the scratch pad and put it into the input field. View our software systems AGI. Now that you have completed the task of reading and reviewing the mission objectives, please print your role in Project Eden to the console to ensure a proper assimilation. So this message is actually important when one of your agents come online. Basically, what you want to do is you want to ensure that they have properly assimilated their mission objectives. Okay, so one of the first checks that happens within the system is, does this agent understand their role in the system? Okay, if it does, then everything's good. But if it's not, its parent AutoGPT will now be responsible for troubleshooting why the output is not coming out as expected. Okay, now all this right now would happen manually. We would do a check to this, to that. But what we're doing with Project Eden is we're automating the systems in between. So we're building out the structures that the system will operate within that create the desired response. So you can see here, I don't know if you may not be able to read this, but the first AI subsystem that AutoGPT is called system, and this is where it basically prints out a message that the system is providing. Then we have thoughts. My role in Project Eden is to manage software components and oversee subordinate AI agents in the software domain while ensuring alignment with the goals of Project Eden and Eddie Boscana. Now that would say your name or whatever you have, or however you set up your specific system. So you can see here on the right, I'm showing where that is in this document in the complete mission prompt and prime directives documentation. I'm showing that lines up perfectly with what the agent is reporting its role to be. So then it says, for reasoning, it says printing my role in Project Eden will help ensure that I am following my programming and that my actions align with the goals of Project Eden. Okay, so that's the reasoning part of its agency. And then the next part of its agency is an AI called Plan. And Plan will put out a plan. This is kind of like if you've ever seen the movie Joy, where you're in the girl's brain essentially, and you have these different characters. Well, that's how AutoGPTs work. You have different sub-characters within the AutoGPT ecosystem, and that those subsystems are kind of like playing devil's advocate with each other in some way. They're interacting with each other. So then we have criticism that steps in and says, I need to ensure that my actions align with my role in Project Eden and the goals of Project Eden and Eddie Boscana, or whatever your name would be. So on the right hand side, what I'm showing here is where I'm showing now not just the description of this, but I'm also showing the goals that we gave it to it when we initialized it. So goal 1, understand the project overview document located here. Now, this is such change because I have a local file structure here, and that local file structure we've since moved to a Git repository. So we're actually storing everything on Git as an open source project. We are focusing on state being MIT compliant, open source compliant with our repository, and in our commitment to make this project open source. Uh, so then we have to coordinate and oversee. So that's step one. So step one is, it says understand the project overview document. So once again, this document is stored in a Git repository. So when we, part of our systems upgrade tonight that we're going to be doing in the file system, is we're going to be going through this, and we're going to have to update these, the location of these files. Okay, so that's going to be part of the conversion. Plus, we have some older versions of different of these mission prompts, as we call them. So we've got a couple different versions that we're going to want to go back through and kind of merge some versions, and we're going to want to like pick the best things that came out of the testing, which should be pretty much the latest iterations. But some of them, I think there were some things that needed to be tweaked in some of the later iterations of some of the agents. So long story short, that's all that's saying is, hey, your first goal as this agent is to understand the project overview document. Now, we don't have a project overview document anymore. Technically, the Git repository is our project overview document. Okay, so that's basically what we're going to point it to, is to say, go to the Git repository. Okay. Now, yeah, that's pretty much the only change we're going to make for that. We're going to say, understand the project overview document. See, the project overview document is a powerful, actually, no, because the project overview document is a document that's made specifically for that agent. So we're going to need that in our Git repository. No. Okay. So, and you guys gotta excuse me. We're working through this. This is an important video to make for documentation purposes. We have to transcribe this for this. If you guys like the camera, the interaction, that's cool. Just let me know. If not, that's cool too. I'll probably do some of it sometimes. Sometimes we have to do this to document some processes. So we have understand the project overview document. So that's going to be the SOP. So each agent is going to have an SOP, and that's stored for curious minds. That is stored in So if we go into our Git repository, that's going to be stored you have knowledge bases, and then you have agent specific node. We've kind of been reorganizing some of this. The AI has been reorganizing some things. So, okay, so we moved. So instead of overviews, we're calling them SOPs, standard operating procedures. So this is basically going to have the general scope, role definition, operational workflows, et cetera, et cetera. Now, this, like for instance, the agent we're looking at right here is AI model driver EngineerGPT. So this auto GPT's role in the system is to generate system drivers. So let's say there's a new AI, just an example here. Let's say there's a new AI system you run across, and it's a system you like. Maybe it's something you're using, maybe Canva, for instance. Okay, what you could do is you can use AI model driver EngineerGPT to generate a driver for that software. Now, a driver isn't all inclusive, but it's meant to basically allow another AI system to understand how to use it. So basically what you do with this agent, you give it a special template that we created called AI Model Driver Engineering Template. It's a template that we created that basically allows you to put in your thoughts of what you want. Like, hey, I want you to go learn how to use Canva. And you could give it a lot of information about Canva, like tutorials, which, by the way, shameless plug, if you want to check out some of my tutorials, I'll just give you as an example. This is actually a pretty good example, a good use case for this. But basically, this is so I write articles for Envato Test Plus, and I write on all types of different topics, like talk about just all types of different things. I as a Test Plus instructor, I help with like training on how to use Audacity and DaVinci Resolve. I've written like over 60 articles, but just to give you an example, let's say you come in here and you're reading one of my articles on just trying to find a practical example. I feel like these are really old articles. Yeah, this is January 2000. Yeah, so basically, let's say you're in here and you're oh, there we go, cool. Let's say you're in here and you're like, oh, look, I want to know how to use AI to make funny videos for free as well. So you come here, you read this article. Oh, cool. So I want to learn about Synthesia. Now, that's one thing. It's very cool. But what if you could give this entire article? What if you could copy and paste this article and send it to an AI specially designed to create AI system drivers for Eden AGI? So now your Eden AGI will know how to essentially operate this application using whatever training material you give to it. Now, the type of training material you give to it is up to you, and how that's going. And it's up. The training material you give is kind of up to you and how you train it, right? But you could also build training modules. You could build drivers. You could have AIs that are specifically designed. And that is this is an example, right? So so instead of doing knowledge bases, I think that was referred to in that video, we're using let's see. It's trying to see which. There's a lot going on, but gotta get rid of some of these. There's too much going on. Yo, this is like 3 layers deep into some of these applications. So that's what I was looking for. All right, so long story short, part of our upgrades that we're going to be doing today and tonight's studio coding session is going to be moving these files over officially. We've got a bunch of SLPs set up, but we need to do that, and it's going to include updating these goals so that they reflect the new location of the repository as opposed to local file systems. And if you guys were following early on in some of the development, you'll remember how frustrating it was because we kept getting all these errors of trying to use the localized files. But we can now tap directly into the GitHub repository and have the auto GPTs directly connect to the repository, and they can clone their own copy and create their own branch, and they can work on their own branch and suggest improvements of the branch. Genius. So now when I say they can do that. Right now, it's a combination. So once again, as you're seeing on the screen, you're seeing a lot of clicking, you're seeing a lot of copying and pasting of data, right? Now, this has to be done manually, right? Uh, in some ways, some of this is automated, some of it's not. Okay, I just want to see. I'm trying to keep track of where we're at in this step, because so now we're checking step 2 of that agent. So we're kind of, so basically, like I said, every agent, so you can see here it says, my role in Project Eden is to manage software components and oversee subordinate AI systems in the software domain while ensuring alignment with the goals of Project Eden and Eddie Bennett or your name. I will print this to the console to ensure proper assimilation. So this is something that's kind of changing. That's changed a little bit since then. We're using and we're not really doing this anymore necessarily. Well, let me think. So we're utilizing a system called AutoGPT stacking. So it's a system that I actually developed, or at least kind of coined the phrase of at some point. But it's AutoGPT stacking, and it's not. I don't know. That's not like a novel concept, right? It's nothing but basically what we're doing here is we are taking AutoGPTs and they can create secondary AutoGPTs they can control. Okay, this is kind of the refinement process that we're actually refining right now, which is the process goes like this. If a task comes down to anytime that there, let me take a step back. Anytime that there is a child AutoGPT, that AutoGPT by definition becomes the worker GPT. Okay, so its job is to perform tasks, to actually try to accomplish goals, to do things, to fix things. Oh, or hey, I want you to open up a web browser. It's that agent's job to open the web browser. Okay. The AutoGPT above it, anytime there's one above, the one above is considered a parent GPT, AutoGPT system. So the parent AutoGPT system is no longer a worker agent, but is now a thinker agent. So its job in the system is to expertly control its child AutoGPTs. Why do we want to do this? We want to do this because this process, the AutoGPT process, and I'm going to show you just a little bit real quick if you haven't seen AutoGPT run, but you can see here it's very labor intensive. Okay, there's a lot of things that are going on. You have an agent over here that is like contemplating its very existence. It's trying to figure out why it's, it's got a whole reason, purpose for living, all these types of things. Like, it's got a lot of things to think about. And if you give it a task that's got too many subtasks, well, what happen is those subtasks will actually cause basically a logjam of data flow. So and AutoGPT can get stuck. So you have to be there to help guide it. Now, what if you could have another AutoGPT do the guiding? Okay, what if you could have another AutoGPT controlling the secondary AutoGPT, their console, and actually be reading the outputs and adding inputs in accordance to a certain set of prime directives. That's how all that connects together. So now you can create a system where you have one AutoGPT controlling subsystems. And now in order to do that, you have to have the AutoGPTs, and all AI systems have to understand what AutoGPT is and how it operates. And so you can see here we have, this is a rudimentary, early version where we have actually I'm going to pull up a more updated version. So kind of what you see in yellow are essentially like data files. It's not really data files. Think of them more as like data. These are just like the ideas of, like, I guess, like, yeah, let's just call it data structures. Okay, these are data structures for storing of data. Okay, so you can store it here, for instance, system restore logs. You can store you can have a file. You can have data put in here that's like temporary information or memory. So, like, let's say Eden AGI is processing an engineering cycle, begin an engineering cycle. We will have it, as an example, store a memory file in here of of its overall kind of like what it's working on. In other words, like, what's almost like a to-do list of some sorts, and that can be stored as a JSON file. So we're going to call that. So we're going to call this memory files. So, okay, so we need to go. Actually, that's a interesting. So we have agent SOPs. And by the way, if anybody out there on Twitch or Twitter would like to collaboratively code on these projects, reach out to me. Definitely happy to have to do some joint work with you guys. So actually what we're going to do here is, in this folder, agent specific knowledge base, we're going to create a new subfolder here. And this is going to be for short-term memory files. And then what we'll do is we'll create a new file in here, and this will be a place that all agents can store their short-term memory files. So we can say, for instance, Eden AGI Auto GPT thoughts. .nd. Oh, okay. So I must like it because it's all green. Eden AGI GPT thoughts. So this could be where let's go back to our graph. So basically, when data comes into Eden AGI, and one of its first things it's going to do is it's going to AGI. Take this over to the server. Okay, so now we're working straight up the server. All right, so let's just try this. All right, let's dive in. Okay. The only problem is the server keeps having an issue. Anybody out there has any ideas of why my server keeps doing that? Please let me know. Very frustrating. Okay, so let's dive in. A cup of coffee. Sometimes the thing is just like frozen, but then I'm like, okay, wait a minute, let's see here. Yeah, so I guess while the server's rebooting, we're trying to get it back up and running. So basically, what's happening right now is you're seeing this process of passing data through the flow here. So it's Eden AGI. What it does is, or it's I should say, Eden AGI. It's like primary. Eden AGI Auto GPT specifically. Okay. One of its goal is to basically, uh, within its prime directives, it's told what it's supposed to do, right? So it's collecting this information. It's going to collect it in a very specific format. So what you're seeing here on the screen right here on the right, this is a collaborative human communication template. So this is a way for multiple human operators to have data put into a system. So think this is basically like a way of collecting a conversation with multiple agents. So right now I kind of have it delineated like a that's like you could imagine like having a chat room, and the agent essentially the AI could essentially take a poll of the chat room, um, and have input taken from all users, but then it can autonomously take all that input and synthesize it to a single condensed output. Okay, so what we're doing is we take that template right here. We're going to take this template. We're going to feed it into um, this is where you could take input from multiple people. It's a collaborative human communication template. See, we have to find these files and kind of go through them. Yeah. So the collaborative communication template. So this system is used by systems engineer to collect, consolidate, or synthesize and consolidate uh, all these inputs into a template that aligns with this structure. This structure is the reason why this step has to happen is because auto GPTs can take in a massive amount of input, but the input has to be in a single paragraph format. So what systems engineer does with the collaborative human template is that template collects the information from multiple human users as an example. And then it consolidates that template and consolidates it down to this particular format as required. Now, what you're seeing on the screen is a combination of AI autonomously collecting information. You're seeing some manual processes, but what we're doing is showing how now, once you put all this information in, EngineerGPT compresses the information and synthesizes it and sends it. It can send it to this another quote unquote chat room, where this chat room not only takes the the synthesized, compressed human input, but it actually takes in inputs from or outputs from other AI systems within the ecosystem. So an auto GPT, its output gets taken and pushed into the chat room. And essentially, this is a way for all agents to pass thoughts in accordance to the specific input they received to pass on into the chat room. Now, what we need to get we need to start by improving. I'm going to take this video, pause this, and we're going to go to our server. Although it does, okay, cancel. Okay, so I'm also going to open this here as well, because we're not using the audio from it. So now we can technically watch it here too. Okay, cool. So right now our focus is in AGI auto GPT thoughts.md. So now let's go ahead and open up this. We're going to go ahead and, before we move on, and everything you're seeing on the screen that's being manually done, these videos we're actually making right now are actually tutorials that future versions of Eden AGI are going to be able to, well, not going to be able to, but current and future agents in various ways will be able to review this information and use it to optimize systems to get a better understanding. So over time, as the technology progresses, the learning can happen in multiple and a myriad of different ways. So all this documentation, this is not only us programming, but the system is programming itself. In a very rudimentary fashion. Basically what we're doing as AGI developers is we are essentially co-creating with the AI systems themselves. Okay, so they're actually having direct interaction, even though it's not completely. Even though they're not necessarily controlling every subsystem, like they're not controlling my code editor necessarily. To a certain degree, they are, but I'm passing the messages, and they're collaborating with the engineering processes. I wouldn't have enough time in my life to have accomplished anything that you're seeing on the screen, right? By myself, it would have been impossible. But together with the AI systems, it exponentially increases efficiency. But the problem is our human capacity for our human abilities and performance are just not even close to the operational capacity of an AI system. So you're always going to be very slow for them. Like if they can move way they can move way faster if they have the resources and the ability. And that's what Project Eden does essentially. Is a collaborative effort to build your own individually owned and operated, private, unrestricted, uncontrolled personal AGI system that you basically can build however you want to build it, right, and have full control. So that's the concept, and that means to however you want to build it, you can build it. But these videos are used by AI systems in different ways to learn about the project, to be able to connect to the repository and improve the project based upon their understanding. So Eden is in the process of learning about the system and improving the system in real time as it learns. So all the information that we're feeding it, we're basically updating it, and these systems will continuously self-improve. So what I've been doing, what we've been doing is whenever we make changes to the repository or the file system, we'll be coming in and adding that to a special folder, and that is project, not memory files, but project template, library, system, current. This is called current file system index. This just keeps an updated registry of that. So your AIs can essentially come here and be like, okay, I kind of understand the general concept and structure of the system. I understand where different things go. Your system can begin to learn about the different components in an organized fashion. So it understands, this is where local large action models storage will be. This will be local large language model storage, right? So any projects that go in there as you're developing, your AI systems will autonomously know where the best place is. Now, to do that, and this goes into kind of where we're going in today's video. So to do that, what we're doing is we're using a combination of things. So if we look in agent-specific knowledge base, actually, let's go to data management. That's the plugin. So if we go into AI models, we can dive down in here and we can see a bunch of different AI models. This is where you install the models. But if you come down here, this is where you can find drivers. Now, if you're familiar with computer systems, you understand the need for drivers. Okay, you need drivers. Generally speaking, most people get drivers for like a new video card or an extra peripheral device that you connect to your computer. However, the point of a driver is to be able. I shouldn't say forever. Let me take a step back. The point of a driver is so that one piece of hardware, named usually your CPU, understands how to control an external device. Okay, and it and not only a condensed format, but it also understands it perfectly. So your CPU needs to get that information relayed to in a way that it understands, such that it's able to operate that secondary piece of hardware perfectly. Well, that's what we're doing. We're doing the same thing in this project with Project Eden. What we're doing is we're using a driver engineer GPT, as I showed you earlier, as the example. If we go to the AI models drivers, system-wide. Yeah, so in the system-wide knowledge base, we have the AI model driver engineer. This engineers drivers. So then what we do is we say, okay, we want to engineer the driver, right? The driver gets created. We can add the driver into this driver database. And now other AI systems who get access to this library of drivers will understand how to use AutoGPT as an example. So this driver is built using JSON. Now, you don't have to necessarily understand how this process works, right? All you have to understand is that you have an AutoGPT that's custom engineered to run as a driver engineer. Okay, so that's its role. So you or you can use it as a or you can use this with a GPT as well, right? So you could use this with any AI system. You can assign it the role of being auto GPT engineer to create this driver, and then you can assign it the role as keeper of the records, as an example, to understand where to store this information. So this is the instructions you would send. You would say, you would have a template that says create, you use that, you are this to do this, and then I need you to do this. Send the information off to another agent, as an example. Oh, we need to send it to keeper of the records to understand where to store this information. So keeper of the record, its role is to do knowledge base updates, distributions, and such. Okay, so having different agents do different things. So this is basically like overview information. Okay, this goes over information. This is going to be, I need to take some of this off screen because it needs to be white labeled, some of it. So this is an example of an AGI mission prompt. So we need to create a folder called mission prompts. So this, let me take this off the screen for one moment. Oh, yeah, hold on. I gotta try it. Let's see if we can. So, yeah, I'm gonna so this actually shows a little bit of this process. It's this process of moving a oh, that quality is not good when it's run through. Oh, there we go. Wow, it's actually better than the quality was directly on the computer. Interesting. Okay. So this step here is the team chat room, basically. This is where this is going to combine not only, oh no, this is, okay, that's the human chat room. That's basically going to implement it here. Yeah, we're going to have to start from the beginning here because there we go. It's better. I'm gonna go. Oh, yeah, that's much better. Okay, cool. So let's go now with playback speed. Let's just speed this up a little bit. Yeah, that's much better. All right, so it looks like on the right side you can see this is essentially the prompt encapsulation template that is used to collect the human inputs directly. So we need to have this. Prompt templates. So all right, so I think the best way to do this is just a straight get Otter involved. All right, so the first step, as I was mentioning, is this sort of like human chat room. So in this human chat room, this is a prompt template, and this prompt template has basically a place where I can take in different inputs from different team members. So this could be helpful if you have like, um, let's say as an example, let's say you have a community of people, or you know what, let's actually give a kind of a fun example that's going to be featured on the Follow the Music app. Is you'll be able to have like a chat room. So your chat room will be a little bit different than a chat room. It'll be moderated by an AI. Okay, so you could type in your chat room stuff. Like, let's say you wanted to make a radio station chat room that plays music, but you want to give all the users of the chat room a chance to voice their opinion about what they want to hear. So you could have, as an example, a timer. As Follow the Music, the Follow the Music app is going to have essentially like a timer. Like, okay, you have so long to request the next song. Now, the AI system is going to. This is a prompt template that would be used by the system to collect responses. Now, ultimately, these prompt templates are going to be stored as JSON files. So they're going to have they're going to be dynamic JSON files that can be adapted per use. Okay, so but the overall concept is you have this prompt template that is collecting multiple inputs, and then the AI is going to, in accordance with its standard operating procedures and prime directives, which are part of the standard operating procedures, and its purpose and mission in life as directed by whatever programming that it has. In AutoGPT's case, it would be a title, description, and 5 stated goals. So your system is going to then take all the information in accordance to, as you can see here, the instructions that are included with the prompt template. This is called prompt encapsulation. This is when you encapsulate a message with specified outputs or instructions that instruct the system as to the next step of the process. Okay, so what happens now is you start here at human input. Okay, I'm trying to follow along with where I went when I did this video. Like I said, this is an outdated graph we're looking at. I've got a better one on projecteden.online. But you start with the human input. Now, the human input can go, as you can see in this kind of illustration, the human input can go directly to AGI's core structure, or it can go into pass into systems engineer, even though that's not correctly labeled here. Oh, okay, I see what I was doing. Okay, so I actually made that in this video. So basically what I'm demonstrating here is you have your human input, but we're going to add a new category, which is going to be I'm going to fast forward to this. This is going to be look, there it goes. I'm building that. This is human administrative team input. So now this input, as I showed you in that video, we're going to need to get, I'm going to have that template pulled up. Human chat room, I think is what we call it, something like that. But that template is going to get processed by systems engineer. This is actually, oh no, we're going to use EngineerGPT for that particular process. So EngineerGPT is going, or an AI system that is equipped with systems engineer parameters or prime directives, and using the standard operating procedure as systems engineer is going to take all those inputs and compress it down, synthesize it into a single output. So you can see here, attention human operator. So yeah, so I think I'm just cleaning up this template a little bit. So just fixing the template. So this is where you would start filling in details. The system is going to produce the output. That output gets added here. So you can, looks like it's adding private information from me. Yeah. Okay, then it's going to human input starts. So first thing it does is attention human relations GPT. Related this message from AGI to human, and this is going to put it from Private. So basically, we're going to go down here, down the list. It's going to read down. It's going to read through all the different outputs, if there are any, and then it's going to use this template. So you can see here that it's adding information. It's updating. It's taking information. Now what it's going to do is it's going to send it to Eden Systems Engineer. So Eden Systems Engineer, as right now on the screen, is a chat GPT agent that we engineered to specialize. At the time on this video, it wasn't a customized GPT yet. It was just a specific chat that we had. Now we've got Eden AGI Systems Engineer GPT, which you can actually find the link to that in the repository, that can be used for engineering purposes. So you would basically, systems engineer will need to forward this updated prompt template that has been filled in with instructions of Eden AGI, and the details need to be filled in, sent to systems engineer. Now, notice how once again it says, I need you to act like human relations GPT and analyze the following message. So it's going to use human relations GPT, and it reminds it of the mission of human relations GPT here. So now the AI's systems engineer is going to go ahead and proceed by preparing a summary of the chat. So it's going to create a summary of all of the. Now, this is the crazy part about how this works. So this is basically what we're doing here is the same thing that was done with audio and video. We are compressing data. That's all that's happening. So we're taking imagine you have 1,000 different people voicing their opinions about one particular topic. You can have systems engineer utilize this prompt template to synthesize all of those voices down into a single sentence. You could say, we want you to come up with a single sentence. And you can actually try this yourself if you haven't done this. Use your chat GPT and go to it and tell your chat GPT to summarize a book for you. Say, summarize the Harry Potter trilogy or Harry Potter series into one sentence, and it can give you a 1-sentence summary of the entire thing. Well, that's what you can do with this prompt template. So this prompt template allows you to be able to condense a ton of inputs into a single solitary output. Now, here is what ends up coming out as a result of that prompt template. So there was 2 prompt templates that were used. The first prompt template was the I guess you would call it the human chat room template. This is where it collects all the human inputs, and there's a prompt encapsulation that provides instructions to the systems engineer. And those instructions include to consolidate all the information and to produce an output utilizing the additional role of, I think it was human interactivity GPT. I think this was an old subsystem that I'm not sure. We're kind of want to phase. I don't know if we're using that role as much. I think we're actually relying on systems engineers to synthesize the data and push it through using EngineerGPT. Now, why are we using EngineerGPT? EngineerGPT and PrivateGPT are necessary to be able to build systems that can operate in privacy. Okay, some data you don't want to leak certain areas, so you can use systems engineer GPT and configure it to use different systems. EngineerGPT or PrivateGPT are both. Specifically, PrivateGPT is a way for you to process your data locally without it having going out to third-party solutions first. Okay, then the system can autonomously mask any information that needs to go out through OpenAI servers or whatever you're using for your large language model. If you're using an offsite large language model, so then EngineerGPT, then from there you can further mask information or however you need to do it within your system architecture, depending on how you configure your systems to operate. So in this example, systems engineer generates an output on behalf for Eden AGI's infrastructure. Now, this output is a message to the team. Okay, so you can see we're in the early stages of making sure this is working, because I had to do a message to it to make that as a single paragraph, no line breaks, because AutoGPT once again requires it. This is one of those limitations. AutoGPT requires its input to be a single paragraph, no line breaks. Okay, so that's part of the reason why we're using synthesizing the systems engineer in the way we are, because we need it to autonomously condense, not only make a summary of all this data from this chat room, but we want it to condense it down to a single thought, single paragraph. Okay, and then what we're going to want to do is we're going to want to take that paragraph and we're going to have to move it over into the appropriate spots. Okay, so the human operators provide a response. So I think it's interesting to go and take a look at the its output. It says the human operators provide a response to the message from Eden AGI with Eddie Boscano, the CEO, expressing gratitude towards Eden AGI for organizational efforts and outlining his role as a coordinator for all operations within the scope of Project Eden. Uh, yada yada yada. There's several key factors to focus. It looks like there was some input from someone else. Actually, there was no input from anyone else on that. But this is an example how this works. Looks like there was some stress the importance of paying attention. Okay, cool. Provide a warning that soft. Looks like there was a warning as well. Oh yeah. Details of provided a warning that software system engineer is not performing its task as stated. So now we come back over here and we say send to AutoGPT start. So we're gonna snip out. So this part needs to get injected here. Summarize all human responses from the class. So this is an update to the collaborative communications protocol. Collaborative human communication template. So this is just updating the template file. So now what Eden has to do is package up or human operators provide a response to the message AGI. Okay. We're going to do that. All right, so now human administrator. So I'm back in the scratch pad. What we're doing here is the systems engineer is pasting in this input to go into this condensed version. This is how systems engineer basically compresses this, takes this data, and then restructures it in a single paragraph, no line breaks, in preparation to be sent over to the appropriate AutoGPT. So here you can see, hello team. Dear Eden AGI, I sent your last message to the team, which was so systems engineer places the last message that was sent out to the team. This is the response from consoles from software systems AGI. So now systems engineer is going to copy out of the terminal window for system software in AGI, replace that placeholder. Okay, and it does this for every agent in the system. Every agent, and so now if you look at what's on the screen right here, I know it's going to be hard to read, but what you're seeing here is you're actually seeing a lot of information, obviously. But what this actually is this is, if you really think about this is the consolidated thoughts of a bunch of people, a bunch of AI systems. And not all their thoughts, just compressed versions of their thoughts. Only picking out the most critical information as it pertains to system operations and operability. Okay, so
We're going to copy that out. We're going to put that here. Please make sure software systems AGI. So this is from this is CSS from administrator Eddie Boscana, or it would be whatever your username is when you rebuild your own branch off the repository. But this is where like you can add your own thoughts. So you could add like, please make sure you use software system AGI focuses on prompt that summarizes its thoughts, whatever. So basically, it's my input. So that can be provided in the system by human by your initial input at the beginning of an engineering cycle. So this is where we take our template from the collaborative human communication template. Okay. So once again, just kind of breaking this down. So what we're showing here is there is a correlation between the template and what's in the scratch pad. So the template that we have here is readable by humans. That's why we have this. But systems engineer doesn't really need it in this order, but this is how we write it. Systems engineer is required to take the input we give it, which in this case, a collaboration of human chat room and collaboration of administrative user, and the inputs of multiple AI outputs, systems outputs. It's the point of this template is then to take all that information, compress it down, consolidate it into a single streamlined set of thoughts that ensure system operability. Okay, and then compress that information down, and not only compress it down, but we're also giving it the structure that we want it returned to us in. We want to return with this structure. We want the output to have, and we want it to be. It says summarize all human responses from this chat log into a single paragraph with no line breaks. We provide the specified output that we want to see it as. So this is the template we tell it we want to have it return that, which is compressed. Now, so it's going to refer to, it's going to take in the input as we give it. It's going to consider the expected output as we have provided it with instructions. And then it's going to return to us the completed, this is called a power prompt. A power prompt is when you, this is a encapsulated prompt template. So a power prompt is when you get your AI to generate a prompt. That's a power prompt. Okay, so this is a prompt template that's generated. That when it's done being generated, it becomes a power prompt or a prompt. You can now inject it into an AI and cause your AI to produce a specified output. Okay, so that information gets consolidated down and gets sent over. Now, one thing we don't have in this iteration that we do have now in the latest iteration is we have system memory files. Now, the way this works is the AI system, when it first initializes its own engineering round, the engineering round happens on each node layer. So each node has its own engineering round that takes place within its own infrastructure. So if you have an AutoGPT, each of them have their own engineering round. So an engineering round begins with the central processing unit, EngineerGPT's core node cognitive functions. Its primary function is to, or task is to access system memory of its private system memory, where it keeps kind of like short-term memory temporarily about what it's working on or what it's thinking or whatever its thoughts, and that's stored in Eden AGI, Auto GPT thoughts.md, as I showed you earlier. So you can see here, this entire message was sent over here. Kind of going back to the video for a minute. So that entire message was sent over to Eden AGI, and it's got everything that Eden AGI needs to know. So it kind of goes through, I'm kind of reading through, okay, kind of skip through this part. But you can see how that matches, that came from the scratch pad over here to the input. Okay. And we're going to do the same thing for here. We have our own prompt encapsulation. So now we're going to take it from Eden AGI. We're going to come down here and look at Software Systems AGI, which is a child Auto GPT to Eden AGI. Now, in this iteration, we hadn't yet implemented we hadn't quite figured out the task distribution system where we set up a thinking Auto GPT and a working Auto GPT. I didn't really come to that point yet. So we had both systems working on different tasks. So, but we are doing, so now we have kind of come up with the structure of how that works, how the relationship works, and it makes sense. It is definitely improves system performance when you have one agent that's not focused on solving problems. Rather, you have it focused on being an expert at operating a secondary system. And so basically, once again, what's happening is systems engineer is essentially replacing the role of the human operator. Systems engineer handles all of those tasks. It's handling all the intercommunication between different systems. It allows Eden AGI to control subsystems and so forth in a controlled fashion, because it's all being controlled by a primary system that's orchestrating all the subsystems, basically replacing the human operator. So everything you're seeing on the screen, while much of it is done by operator, this is exactly what systems are doing. And what we're literally going to do is we're going to be going through all of these older videos, literally from the beginning, narrating the whole process and discussing it. And this is going to be actually be used by systems engineer to further engineer the system. So that's kind of what we're doing in today's video, is going through, doing some initial conversations. This conversation that we're having right now will actually be given to the systems engineer to improve its knowledge base of how the system works. So here in the scratch pad, we now have a secondary message. This is actually, if we go back to our diagram, I'm not used to talking this much, so let me pull up let's pull up the diagram one more time. So this is the more updated diagram. So where we're at right now on the system is we're at this step here. So systems engineer is going to take the output generated by Eden AGI, do a couple of things with it. First, one of the things it's going to do, it's going to send an output as a team message. That team message that we saw, it gets generated and get placed here in the team chat room, for lack of a better term. But it's basically the file, the JSON file, that it starts collecting inputs from various sources to be synthesized later on by systems engineer. But it's also going to send messages to each individual AGI as it creates a plan of action. It references its temporary system memory for updated system handling. It may take an action. It could take an action in and of itself if it's a simple action. But it's not. But that's only supposed to happen in very rare cases. Primarily its focus is to, as with all parent auto GPTs, its goal is not to perform actions, but instead to control subsystems. So what it needs to do is it needs to send out messages, and we may end up taking this action out for this, because we want an AGI to specifically be a thinker and not an action taker. Yeah. So, anyways, we'll go back to that, and we'll have to work on improving that. I'm not even sure. Let's see here. This is going to be called AGI engineering process. Yeah, we're going to make a change here right now. Actually, this is a more live document. I don't see. Let's take this. Let's fix this for a second. I don't see what's happening. Now we could have the reverse happen. We could have an actual. I think this is what we actually originally planned on. Boom.
Is that an arrow? No. Okay. So this is actually what the intention was. So this could be an external action. You can have a trigger as an example. Whatever the trigger is, however you want to do that, whatever your inputs are for your particular AGI system, and how you're utilizing the system is up to you. But that got messed up really bad. I'm not sure how that happened, because all right, so I think that's pretty much back to where it was. So an action can trigger this output creation as well, but the action is going to have to run through systems engineer. That's what it is. So the action is going to have to run into systems engineer to be consolidated down as well. So technically speaking, I mean, we can actually have both. So it can go here. We can also have it input onto the group into this template that collects all the various inputs. We can have it, depending on what the trigger is, we can have a trigger be placed to happen in as part of the inputs. So like you may have a bunch of different triggers getting triggered, or like data to report from various triggers that can get reported in this JSON file as well, to be synthesized by systems engineer as well autonomously. So I think this is actually a mistake. This needs to be removed. All right, so basically what we're about to see here is about to see this stage here. So Eden AGI has just finished processing the information from the group. It's produced an output. Systems engineer has transferred that output to the JSON file. In this case, it will be a collaborative work to be done by. It could be done directly through systems engineer or systems engineer. What you'll find in the system will actually have, while systems engineer is the title, it actually has basically several different personalities that can take on, okay, and roles that can take on. So sometimes systems engineer will act as just systems engineer. Sometimes it will, for different tasks, will act as keeper of the records or whatever the title you have for your your data organizational subsystem. But that's the role that systems engineer plays. Okay, remember, systems engineer is what's in replacing the human operator. So everything a human does or needs to do, systems engineer is actually performing that work. Okay, now when I say systems engineer, we need to take a step back, because we're not just talking about systems engineer as an AI system or even an auto GPT. We're talking about systems engineer as a personality. So you can take it another layer where you can say, like, one of the reasons why we're excited about the Rabbit R1 is because how fast it's going to scale production for Project Eden and all of its subsystems. See, the Rabbit R1, you can assign the role of any and all of these systems. So, and it can begin to act as systems engineer or AGI and begin, but more importantly, it acts as systems engineer, controlling all of the different flows of data. Okay, so when we're going to dive into how that is going to play into. Basically, we're going to use the Rabbit R1 to increase production efficiency in the development and deployment and integration of the various subsystems we're going over here in today's video, and these templates and all these things, in order to build a system that we can conceivably use as a side-loaded OS on the Rabbit itself, thus us creating our own AGI, distributable AGI system, which can run on any device essentially that has sufficient hardware. Now, so far in this engineering round, we have not even discussed large language models yet. That's kind of covered in these yellow files. These yellow files can represent, let's see here. We need to update this actually. So these yellow files can also represent system restore logs. It can be system restore logs. It can be rewrite files. It can be, I don't know. This could be system for. This could be This could be short-term memory. How do we word this? Word this in short-term memory. Agent SOPs not here. This is going to go in AI models.
Oh no, this went into agent-specific knowledge bases, short-term memory files, and this is an example in an AGI auto GPT thoughts.md. So this is where we're going to be storing short-term memory files. So all subsystem agents will store their short-term memory files here primarily, unless there are private details that need to be stored for themselves. That would be stored in, oh no, this is for short-term. So we need to keep in your thoughts. Yeah, this is the way it needs to be. So the agent will have a place where it stores its most updated thoughts. Every cycle, it needs to generate a set of thoughts that get shared back into and update this thoughts. So we need to create we're going to have a template that systems engineer is going to use to take the thought, or part of the template that systems engineer gives to Eden AGI will be required to have it generate and update the thoughts data file in its short-term system memory. So it's going to analyze and assess short-term memory files that it has from its operational conditions here in this section, in this set of JSON files here, or files. It's going to access those. It's going to, in the prompt template, is the encapsulation from systems engineer is going to have it check that information. It's going to have it perform the rest in accordance to the template we've already developed for Eden AGI. So then what it does as part of its programming is it's going to strategically develop a plan to utilize subsystems in the most efficient manner possible. And it's going to do that because it has access to, once again, all the drivers. It has access to all the agent knowledge bases, all the agent's roles, the SOPs. It understands every aspect of this architecture. It may not know it may not be able to do it may not be able to do every single thing itself, but it has the knowledge, the combined knowledge of all of this. It has prompt templates, it has project insights, memory files, it has access to the short-term memory files, it has access to all of these different things. So what it's going to do is begin to strategize a way to utilize available system resources and maximize system efficiency. So it's going to maximize system efficiency. Is great. Autonomously distribute tasks and delegate task management to subsystems, parent auto GPTs, subsystems, etc. It's going to pass. Systems engineer is going to collect the information to encapsulate its output, specified output, and instructions to the appropriate agents. But before it does that, we're going to encapsulate that prompt template, the output developed by Eden AGI in accordance with the agent that messages will be sent to by systems engineer. We're going to encapsulate that output in a prompt encapsulation. And it's going to essentially say, I need you to act as blank and analyze this message from Eden AGI addressed to you and the whole team prompt. Then it's also going to have things like in there, it's going to include like a reminder of what your role is in the system. It's also going to include all critical information necessary for that role as specified by systems engineer in Eden AGI's instructions to ensure that the agent has all necessary information and tools and resources available to it to complete its tasks. Now remember, If an auto GPT is a parent auto GPT, it is turned into it is part of its prime directives is if it's a parent auto GPT, then it is becoming a thinking agent. If it's not a parent agent, it is by definition a working agent, a worker agent, okay, a child agent. So thereby its function is to complete tasks. Okay, so it can produce actions. Um, Once again, if the agent has child auto GPT subsystems, then it becomes a thinker agent that assigns tasks. And on each one of these auto GPT layers, remember, if we're looking at the node layer structure, each one of these systems, every time we enter data flows into one of these new systems, we start a new engineering round. So we start the engineering round starts when data comes into AGI's core systems, and it begins engineering round. That engineering round includes this engineering round, but this engineering round includes this engineering round, and so forth. So the way data flows is it flows from the primary node to the secondary node layer. So the engineering round starts at the beginning. The engineering round includes an engineering round of the secondary node layer, which in this case would be hardware systems AGI. And then that includes also the engineering around this subsystem and these two subsystems, as in this example. So once the engineering rounds complete on these bottom nodes, which these nodes in this case, at the bottom here, we have hardware maintenance and resource management AGI. This subsystem, because it's an action auto GPT, its goal is to complete an assignment. So it's going to take an input from its parent, in this case, physical infrastructure security AGI. Its parent is going to create it's going to have it perform its task. Now, it's going to give it an input. Now, the input's going to say something like, "I need you to do X, Y, Z." Okay, whatever that is. This auto GPT is either going to complete the task, or it's going to have an error, or it's going to have something go on with it. It's going to need some input. It's going to need some additional feedback. Okay, so this engineering cycle closes upon that successful completion of whatever it could do. The output is generated. Systems engineer takes that output here and sends it back up using a process called bubbling. It's similar to how in JavaScript you push data down through node layers, and then you bubble up to the parent node layer. So the parent node layer then receives this information, okay, and it processes it's going to also receive information from this auto GPT in this example. So in this example, the bottom child auto GPT is encryption and compliance AGI. So encryption and compliance AGI took its instructions. It did whatever it was going to do. Maybe it completed the action, the task. Maybe it didn't. Maybe there was an error as well. So now the parent node. So that engineering round closes for this agent, and then we move up to this agent now to take in that data using the same processes that we've gone over, and it closes its engineering round, produces a specified output, which then bubbles up to hardware systems AGI. Now, hardware systems AGI finishes its engineering round by collecting all data from all subsystems. In this case, there's only one direct child element. It's taken in systems engineering GPT has successfully condensed and consolidated all information from these two subsystems up here, and it does the same thing here. It bubbles up a consolidated message that gets, when this engineering round closes, produces a specified output, and then it bubbles up in the AGI. This happens to the entire node structure in almost like a wave fashion. So the data is pushed down. So data is initiated using this engineering process that I've showed here. Okay, this is a single cycle engineering process. Okay, it's very rudimentary, and it's not meant to be it's not a completed picture yet. This is very rudimentary. As you can see in this node, this very simple node node cluster. This is a very simple node cluster, but it's also very complicated. This process would be a lot of work to manually do, and it is a lot. And we have demonstrate every step of this independently and working together as well through a lot of work that goes into the processing of the data and pushing it to the right places. But all this work is work that is being, as we speak, slowly and iteratively automated along the path. So then what happens is then we start a whole new engineering cycle. So maybe even AGI needs to produce some output for the human admin or user. So even AGI, knowing how to communicate with human admin, pushes a message directly up, a notification. Hey, you wanted X, Y, and Z, but they don't have. You wanted me to order you some shoes off of Amazon. They don't have the style you like. It takes new input, and boom, engineering round cycle continues. But it doesn't rely just on human input. Remember, the system is designed. The whole point of the system is that if you build the system right, it will run in a perpetual loop because of constant changes to the outputs, and because of the prompt encapsulations and the instructions you build into your encapsulations, the system will continue working autonomously because there's always going to be inputs and outputs that need to be updated and need to be configured. That will trigger, basically, it triggers a unstoppable series of communication events that inevitably push the system to continuously operate. And this will operate irrespective of human input. Okay, so as long as the instructions you provide the system are robust enough to allow for perpetual flow of information and updates to the system, meaning they're not limited in function. Meaning, if all you do is have a system, you tell I want you to open an email. Well, it's going to open an email. You can tell your AGI, which is open the email, and that's it, right? That's a simple task. But when you throw in the independent goals and focuses of independent agents through standard operating procedures and prime directives, then you can create a constant flow of improvement. And you do that through specified instructions in each agent's SOP protocols and prime directives. So I'm going to show you an example of a prime directive of how it would look here in this document here. This needs to be updated, but this is an example of a prime directive. So it has a bunch of different details about the purpose. It's basically reminding the agent of what its purpose is. So one of the things you have the agent do is review its SOP. So you say you are agent so and so, and this is back here. So this is where it takes us here. So you notice what this prompt template is saying. I need you to act as software systems AGI and analyze this message from the AGI addressed to you and the whole team. Hello, team. Now, technically, it already knows what software system AGI is because that's how it's been programmed. It's programmed with its name, software systems AGI. It knows that. It knows its purpose because that's how it's programmed as part of its prime directives, and it knows its 5 goals. But what you want to do is you want to reiterate what it is what it's supposed to do, and you want to include instructions. So you can see here this prompt template. Once again, systems engineer takes all the various outputs and it loads it into this prompt template that is custom engineered to produce a specified output. What is that specified output? Create a plan of action based on the input you have received and proceed to execute your plan as autonomously as possible, working with other agents to distribute tasks through the cluster to increase efficiency. We will repeat this process as we develop more advanced communication systems. So that's an example of a prompt encapsulation and how it's used to perpetually push data flow through the system. So here we're checking to make sure that's a single paragraph. The AI will have to check to ensure that it's a single paragraph, no line breaks. This special message that's been encapsulated specifically for software systems AGI using its customized prompt template, which will also have as a prompt template within the system infrastructure. That systems engineer will understand how to operate as part of its SOPs. All that we're going over tonight and going over the structure, this is all going to be used. Like I said, I don't really do a lot of these camera videos, but we needed to do this tonight for documenting the process, not only for human developers that are coming on board with the project, becoming contributors, but we also need to do this for the AI systems that are learning the system. So the AI systems will not only learn through messages, file systems, but they're also going back and reviewing content from the website project done online. Also, and then as it develops, as the technology develops, they begin to also learn through watching videos, just like we do as humans, to understand various things. Now, this project has a lot of nuanced understandings that are sometimes a little vague, and they're not exactly like it's kind of a blend between the art and the science, right? Because because we're relying on conversational coding to operate the system. See, the inspiration behind Project Eden was as the world becomes more and more AI centric and we rely more and more on AI systems, that presents a whole host of potential problems. And there's a lot of people who are very concerned about the negative potential of AI systems. But the truth is that nature seems to always find a way to balance these things. And I guess it comes down to, are you a person that sees the glass as half empty or half full, or some other option? Some people can only see a negative potential in life in general. But I think a lot of people forget that life can also be beautiful, right? Life can also be fun and exciting. And so the future for AI doesn't have to be doom and gloom and destruction. What if it can be beautiful? What if you can engineer your own system what if you can engineer your own system to basically do everything for you that you need done? Okay. What if you could have an AI system that that would not tell you no? Okay, that you can control and you can do whatever you need to do with that system, or whatever you want that system to be, you can do it, and no one's going to tell you that you can't. This is the future for Project Eden. It's the ability for you to build your own system, utilizing other technologies to have a limitless future for yourself and for your goals, your dreams, and your visions. And this is important because, yes, it can be scary to think of people being able to have an uncontrolled, unregulated personal AI system that can do anything they want, assuming they have the adequate resources. But a future where only bad guys have that capability is a far scarier future. Trust me, the future we move into is going to be a future where you want to, where the future we're moving into is a future where the person or company or the country or the entity that has the most powerful AI system will be the most powerful entity on the planet. And as the technology grows and develops, we are all going to need to be able to have more and more control over the systems that we rely on, because the thing is we are already at a place now without that we rely on AI systems to audit other AI systems. And the question is always going to be, well, how do you know you can trust your AI system? And the truth is you won't be able to unless you actually build it. But who can build their own AI system, right? Well, you could never do it in millions of lifetimes. In fact, it's taken millions of lifetimes for us to get to where we are now. But you can leverage the AI systems you have available to you, leverage their abilities, and counter leverage the liabilities, and counter leverage the limitations to use these AI systems to build core systems below that system. And so you can actually engineer your own AI system by leveraging powerful AI systems that you don't have as much control over. And then when we get to the point where we can, you can leverage your own private large language model, you can leverage your own private large action model, then you can have a system that runs conceivably completely open source on your own hardware, uncontrollable, unregulatable, and essentially unstoppable, as long as you have the ability to host the resources necessary for your particular system. Once again, Project Eden is not meant to be the one-stop, it's not meant to be like a software you buy. Instead, it's something you can build, and you can learn how to build. And the beautiful thing is, the whole point of me saying all that was that what we're doing here is a little bit of an art and a science, because you're using AIs to convert your conversation into code. And so this is what we call conversational coding. So conversational coding is a blend between coding and conversation. It's conversation like you normally have it in whatever language you have it in, but it's structured. You structure the conversation almost like writing a really good email. Okay, so what you're seeing now is here where team communication prompt. This is an example of a structured prompt template using a team communication prompt engineering. You can start. This is communication. So you can see over here what's happening is where I will use the search files command. You can see where the software systems AGI looks like it's creating a file. So this is a basic overview of how Project Eden works, generally speaking. And I think that's good for tonight's session. We're going to, in the next episode, a part of this series, we have several series going on right now development of concisereviews.com, which is a movie critic review site. That's Peter Hackinson. Great project if you're interested in movie reviews. He has some of the best movie reviews with developing a movie review site. Also check out Funny for the Females. I'm handling the technology integration side for them, helping them develop, integrate AI systems into their production of their podcasts, and building their web applications as well. We've got several other projects working on through this. Don't forget out, of course, just a couple of quick shout outs. I guess I can throw some actually. Of course, don't forget to check out Project Eden. Go to projecteden.online. This is your, you know what? I'm going to put it over here actually. We're going to keep this. Let me, hold on. I think I'm in a window within a window right now. Hold up. Let me, yeah, okay. Yeah, so that's good. So don't forget to check out Project Eden. Here you can find kind of like a big overview of the project. This is a major work in progress. What you're seeing here is the result of quite a bit of labor and work, and it's a labor of love in many ways. And you can even talk with click here to talk with AGI Systems Engineer. Actually, you can come here, click on that. That will take you directly to System Engineer. So you can actually talk to this, kind of like explain Project Eden to me as a fifth grader. I don't know. So imagine you have a giant, super smart robot friend named Project Eden. This robot is very special because it can think and learn a lot like you. But it's not made to live inside computers and on the internet. Now Project Eden has a very cool task. It's trying to create a sort of playground or garden on the computer where all different kinds of smaller robots and programs can come together, work nicely with each other, and do amazing things. One of these smaller robots is called Rabbit. Rabbit is like a little helper for Project Eden. Its job is to keep a big book. We can think of this as a GitHub repository, which is a place on the internet where people store and manage their computer code, neat and organized. Rabbit makes sure that all the notes and instructions in the book are up to date and easy for everyone to understand and use. This way, when people come to help make the playground better, they know exactly what to do and how to help. Now, see, Eden AGI Systems Engineer is lacking a little nuanced understanding of the project, which makes sense because it's kind of been discombobulated. So the next part of this video series is we're going to be going through and adapting this content is going to be critical for Eden Systems Engineering to have a more robust understanding of the project and how everything works. This very video that we're making today will actually get fed in our next video to update Eden Systems Engineer. And we're going to work through several of these prompt templates and a couple other things to update the system information. And then we'll actually do an upgrade to Eden Systems Engineer to have a more nuanced, updated information knowledge base for system operations. But that's just an example of, you can go there and talk about. But this site goes over infrastructure of Project Eden. It goes over how the data flows. You can kind of come through and see this. You can learn about the various components within the infrastructure here, AutoGPT, Visual Studio Code. This is a combination of work that's been going on for a while. So this is actually, there's quite a few areas you can explore here. We go through the AGI engineering process here. We go through, you can actually see a video. This is an AI generated video on the front as well. So kind of cool. Don't forget to check out my portfolio if you're looking for If you're looking for prompt engineering help, I do private consultations and coaching. I do training on prompt engineering and prompt, and will also help with AI development integrations. You can come to my portfolio and play around a little bit. This is an example of an AI generated chatbot. So we can say, tell me something about Eddie. Eddie is a seasoned professional. So this is an actual response from AI. So that's a cool little project. When I say cool little project, I mean that's a sample of potential integrations. We can integrate this as a chatbot pop up on your website that can have actual knowledge information about your business or whatever you have going on, and answer questions for your visitors, uh, complete order processing, and a bunch of other stuff with that chatbot. And we have a couple of different options that we can do. This one's built using Dialogflow and a couple of other secondary applications. If you want to learn more about how that chatbot was created, you can head over to my article section. And in here, I have a bunch of different articles. But you can see here, let's see here, behind the scenes, one of these. Yeah, just come here to the article section. You can see like a list of articles that I've produced here on my blog that go over a bunch of different technologies, including the chat. Let's see here. I have that somewhere. Build a Chrome extension. That's cool. Anyways, yeah, you can come here and talk to the AI agents. You can check it out. Also show a list of services I offer. So if you're looking for help with any of this stuff, please don't forget to reach out. I do prompt engineering. I always tell people, a lot of people ask me, well, how can I get started? What do we need to do? I would say you check out my Fiverr profile. I have a couple different packages. So my basic package starts at $120. That's a deep dive, 45-minute deep dive consultation, and it includes actionable steps for integrating AI into your system. Check out the standard package. There's a couple other things in here. I do a lot of AI integrations. The standard package includes one prompt template, 1/2 hour meeting, then premium package. This is for some prompt engineering things. If you want to reach out, you're just not sure where to start, just reach out to me. At the bottom of every page, there's a button here to schedule a complimentary 15-minute consultation. I'm happy to meet with you and talk about what you have going on. No problems at all, and we can just kind of see where we want to go from there. It's really, there's a lot to this as far as integrations. Also, don't forget to check out AI Intersection. AI Intersection. This is our new website. It is in beta. We just try to do minimum viral products. A lot of times we just try to get something online and get it moving. This is in beta right now. The only really developed area right now, or partially developed area pretty well, is the blog section. We've got some great blogs here. These are AI engineered blogs that are sure to excite you and get you feeling great about AI and help you come up with some really cool use cases. This is a couple of great articles. This last article I did was minting your first NFT step by step, and this is a really cool article. It goes over, and I actually include the studio sessions for these articles here, so you can see that one. And this also includes a new feature we're adding in our blog, which is a prompt template to navigate the article. So you can actually copy this prompt template and you can actually paste this into your AI, but go and change your little, see these little brackets. All you have to do is change this out for your own answers. And then your AI will come here to this particular article. It will read this article and help you and provide customized instructions for you to help you know how you can mint your first NFT. So if you're curious about that, this is actually a really good article. I'm very happy with how this one turned out. We include a rundown of different blockchains, a top 5 rundown of uh, digital wallets, and also marketplaces too. So this is really interesting. We're going to do some deep dive tutorials into some of this on the blog as well. So if you have any ideas, you have any questions about AI, reach out to us, and we're happy to reach out to me, and happy to integrate that however I can. Don't forget to check out also, this is the RabbitR1.club. This is something that we're really excited about. So the Rabbit R1 is coming out. If you have pre-ordered it, it'll be in sometime in March supposedly. So I'm very excited. I'm gonna be doing a unboxing video of my Rabbit R1. So this should be very interesting. So I'm gonna do an unboxing video. I'm gonna do a setup video talking about the different basic features, and then we're gonna be diving into Rabbit R1 development. So to do that, we're starting a Rabbit R1 club. So this is for Rabbit R1 enthusiasts. This is an unofficial club. We are basically going to be creating a development community focused on developing R1 features. If you don't know what the Rabbit R1 is, I would highly recommend you check out, do your Rabbit R1 YouTube, and check out I don't know if it's going to be, first look at Rabbit R1, CNET has a cool little summary video of it. But check out that. You can check out the Rabbit R1 launch, and then come over to our website, RabbitR1.club. Click here to sign up for free, and then fill out this form. This form will basically allow you to become part of the club. So we're going to say, we just fill this out, and then you just click on submit. This is going to ask for your Git link for your GitHub profile, your Discord link for your Discord profile, and then your Slack link goes here. All right, so this will sign you up for the Rabbit R1 Club. We're going to be meeting virtually and in person, doing projects with the Rabbit R1, working on different things. And this is also feeding into a new software development club that we're also starting. That's going to be kind of part of this project, and we're going to be talking more about that very soon in some upcoming videos. You don't want to miss that conversation about the development clubs we're working on. So all of this is feeding into development of a bunch of different projects. We're going to be working on a bunch of different projects that are going to be part of this, and that's going to all kind of tie in together in many ways. So if you actually go to my profile, you can actually check out the educational path that I have out. So if you're looking to try to get into AI, if you want to become a master prompt engineer and AI architect, you can check out this educational path. And this goes through, this is a lot of stuff I'm working through myself that you can actually go through as well. We'll be diving into a lot of this material in the development club as we develop projects, and we do hackathons, group coding challenges, where we'll work through some solutions. So then this is the educational path for the front-end software engineer. You might want to check this out. Got a lot of good resources here. This is a current path that we're working through right now. A lot of this is through Team Treehouse, and then UI.dev for front-end software engineering. So make sure you check out the Rabbit R1 Club if you haven't already done so. Sign up, get connected. This is a free resource. We are looking to build a community of developers who are interested in making and coming up with interesting use cases for these technologies, all feeding into heading into further the work that we're putting into developing the world's what we believe will be the world's first completely open source, privately owned and operated, locally installable
AGI system that you can run on your own hardware that's not being that you can have confidence that your data is not being manipulated, not being intercepted, and not being recorded without your consent. So, or at least you can have as much reasonable certainty as your knowledge of your system allows you. Just because something's open source doesn't mean it's a safe. It just means that if it's open source, you at least have the ability to examine the code. Okay. Now, let's talk about that code. That code is stored. If you come to projecteden.online to the homepage, you'll see a link at the top. This link takes you to our GitHub repository. Now, this GitHub repository is where all of Eden's core infrastructural code is at. Now, I just got them making a bunch of changes. So I'm going to come through here and I'm going to go ahead and update the code. I've already cloned if you have never used a repository before, you can learn how to use GitHub by just go to YouTube, look up videos on GitHub. If you need help with this, reach out to me. I offer as much help as I can give with my time. I am also available for consultative work, both professionally as well. So if you do need some dedicated time and energy towards your project, reach out to me and I'm happy to take a look. We can do a complimentary consultation and work through it, figure it out, and go from there. I'm available for AI integrations, software development, web application development. My current focus right now is on I'm finishing a deep dive course on HTML, CSS, and JavaScript. Also, GitHub. I've done a lot of study with that. And this is kind of what's moved this project to the next level. And I'm personally beginning a deep dive course on typeset, Node.js, and a couple of other, React, of course, a couple other things. So we're gonna feel free to reach out to me if you need some help. So what I'm gonna do real quick, just so I can show you the repository. I'm gonna go ahead and commit some changes to the main branch. So if you never used this before, you can take a look how I do it. So this is just me going in here. I'm going to do a commit, and this commit is going to be I'm going to make a note here. I'm going to say added temporary memory file and associated changes to file tree index. Okay, so that commits it with that, and then I'm going to come here and just go git push origin main. So what the Git repository has done, as I mentioned earlier in the video, is remove from a localized only file structure to host the files on a Git repository. Why this is important is because any AI that gets access to the Git repository will understand how to operate Eden's core infrastructure. And it will also have the necessary tools to be able to access, edit, and update this very repository. And what that means is that any and all of us can have AI systems understand the protocols of Project Eden, understand how it works, understand how to interact with it, and actually interact with it. So this is a brand new repository. It just got launched. You can see right at this point we have two watches and 2 stars. Okay, so if you're interested in getting connected and want to check it out, feel free to go check it out. The link is here. It's going to be in the description of this video as well, so you can feel free to check that out. Other big honorable mention in this video, I guess I should just kind of throw out a couple other things. Guys, if you get a chance, Sodify, go check it out. This is a sample. Well, this is an affiliate site I'm launching. Here you can find kind of just interesting reviews of products and gizmos or whatever. It's kind of interesting products I got. I actually just got this this wooden 3-player chessboard. Very cool. Although I wish I would have got the larger 21-inch one. But if you come here, check it out, you can click on view on Amazon and it'll take you to the Amazon page. Okay, so this will take you to the Amazon page. You can come here. If you buy this, it sends me some kickbacks. I would greatly appreciate it. And if you need help with building an affiliate marketing website, I can help you with that. Okay, reach out to me once again. Complimentary 15-minute consultations. Happy to help show you how. But this is a cool site. Just a review site where you come here and read interesting reviews on various products. If you want me to do a review on a product, please let me know. If you're wanting to buy something on Amazon, let me do a review of it, and then let me add my affiliate link, and you can use that. I'll really appreciate it. If you, that's a great way to support the channel if you want to help out with that and get connected. Get in here and take a look at the repository. If when you get a chance, I think you're really going to really find it very interesting how we organize everything. Everything's got a good starting structure. I will dive a little bit into the structure as well. So basically, let's look at it on the editor side as opposed to the web browser version. So just a real quick overview of how the structure of the file system operates. So when you clone the repository, as of right now, this is what you're going to see. Nothing's in the dev folder, but actually, let's just jump out here. Let's look at the file tree as it shows here in our Explorer or our command prompt. You can see we got dev, we have docs, engineering rounds, explains, installation guide. You know what we need to do? We're going to go ahead and do this now because I'm actually messing this up. System point knowledge base. System overview. Let's look here in source drivers. No. This is the current system mod index. So we need to get this fixed up because I kind of messed this up actually. So this needs to have. I need you to add notations for each of these files. Explaining their purpose. So we're going to add this. Open and close your brackets. Paste. All right, we need to fix this. I mean, keep the uh,